After opening Cubit, the first step is to open a new project. So we're going to name this project bidding project, for example. So then we press OK. In the new project, we now have to create a new job that will be under the new project that we've created. So this will be tutorial 1. So when you create a job, for instance, maybe you need to create for a specific trade. For instance, let's say plastering. This is where you name it. So in creating the new job, to open it you need to double click it. So give it a few seconds as it loads. So this is how the page looks like after opening. So we have the rate sheets and the estimate, the section where we're going to add the descriptions. The viewport is where we're going to insert our PDFs, our plans, our structural and architectural plans. So this is one of importing. Let me choose one PDF. So I'll choose a site plan first. Now when opening, I usually prefer using the plan as a raster format, so that it usually easy to use, because in the vector format sometimes we have very heavy files that will make it a bit harder to operate in Cubit. So most times I use the raster format, which is more or less the same. So when the PDF opens, we now set the scale. So the first way to put the scale is to draw a line with the given dimension in the folder, but in the PDF. But since, like in this plan, we don't have any dimensions, we're going to use the scale provided in the layout. So I can't see any dimensions, so we'll just give a scale of 1:350. So that PDF is scaled properly, so that when I start measuring, there is no the scaling issues. So this is also another way of importing PDFs. You can just press insert from there, and if you have like in this case you have very many PDFs that maybe we need to use all of them, you can just highlight several PDFs and import them all at once. You can select all the PDFs that you need. When importing a PDF that has many drawings, that is combined, as some drawings usually are, when you import in Qubit, all the pages will be shown, and you'll be given a choice whether to import each as a vector or raster. But in this case, since the PDFs were many, I just selected. You're just going to have to select one by one. You just import them one by one. So we import all the necessary PDFs that you're going to use in the takeoff. So mostly the architectural plans and the elevations and the sections, as well as the structural plans, especially if you're going to take off maybe some elements like the substructure, concrete. So you'll have to scale every time you go to a new PDF that you have not opened. You'll need to scale it. So like also in this one, you don't have any dimension, so I'll just use 1:100. So if you want to scroll through the PDFs, you can use the drop down button and select the PDF you want to use when you're measuring. So you don't have any dimension on this plan, so I'm going to use the one on the title block. So we're just going to trust this scale on the title block, but if you have a plan or a drawing that has dimensions, it's usually better. Like this one has dimensions. Let's test if. So you just select the dimension line that you want to measure, and then you input the length that is given on the dimension. So you see this scale is 1:199, so 1:200 is correct. So the scales given on these plans should be correct, but sometimes we're given plans that sometimes the drafter forgot to change the scale. So in this description box, this is where you're going to we input all our your takeoff descriptions. So I'm going to show you how to take the measurements. So first let's test the length. So if you want to test the length of something, maybe you want to take off something in you want to measure the length of the wall or the foundation, and mostly the unit is usually you want to measure it in length, that is in meters or whatever unit you want to use. You just select and measure the line of the wall that you want to measure, and the quantity automatically shows itself. Now if you want to maybe measure the area of the slab, let's test this slab. So yeah, at home, so on the area you select the quantity section. Now for like in this slab we can use a rectangle shape. You see it covers the whole slab and it measures the quantity is given automatically. So and when you want to test like let's say the volume of also a slab, let's say you're taking off this substructure or the concrete volume. So on the quantity, when you select volume for this slab, actually you can just when you select the volume, you can just use the same shape. So when you select this shape, just press escape so that it stops. Okay, let's use this other floor plan. You see it gives automatically. So in our next tutorial, I'm going to show how to edit the shape so that the volume and the vertical area, let's first test the vertical area is used to let's say measure the length. I mean maybe when you're taking off painting, you want to get the area of the wall that is painted, you use the vertical area. So in our next tutorial, I'm going to show you how to edit the shapes of the volumes and the vertical area, so that for instance, you want to change the height of your wall, because the standard Cubit gives is 2700 meters. So you see, when you're taking the vertical wall, it's for 2700 meter wall. So but if you want to change the shape, I'll show you in the next part, as we are measuring a vertical area of a specific quantity. You can see those are the details of the shapes given. So that is these are a few of the quantities that we measure in Cubit. As you can see, these are the shapes that we have generated so far. Yeah, that shape is the tested the area, we've tested the length, volume, and the area of the walls. So you see in this 3D view, the vertical area is the walls that I've highlighted. These others are the slabs. So one, you calculated the area, one, you calculated the volume. So after taking off, you can see on your 3D how you went about it, on getting the takeoffs. So I'm going to also add the structural plans, so that we can do a sample takeoff, so that you can understand better what I mean. So let's say, for instance, we are measuring element 19. So I'll just do a quick recap of element 19 to 21 on taking off. That's the external walls, the internal walls. So I'm going to draft a sample description, so that we can do a sample takeoff together, so we can understand really, even on changing the shapes. So we have, let me delete this quantity as I had already measured. So let's say we need a 100 millimeter slab. For the floor slab. Yeah, so now we let's add a 300 millimeter by 50. So this is an example of a substructure takeoff. Of course, it varies according to the type of format you're supposed to use in your specific tasks, because sometimes you're told to maybe take off just the substructure part, or even if it's the full building. So Cubit helps you to categorize your bill of quantities well. So let me also add a read-on barrier. So I've added a grid geotextile and the grid dust-free stone and a layer of insulation. So I'm also going to add a blinding. And also 300 millimeters of well compacted stone. So I think that's enough for the element 19. So to categorize this well, you can make this a heading and the rest of the items you can just select by using shift and the arrow button, and then just drag them to below the heading on floor slab so that they are under that section in Cubit. So you can see this is the result where we add the area. Make sure you unselect it, select one so that it's not selected, because when you select them all, the quantities will be the same for the whole all of them. So for the slab, let's start with the volume. So I'll use this floor plan as an example. So for the floor slab, you just take the outline of I want the whole slab to be covered. Yeah, then just join it with the whole slab so it forms. I don't think there's a corner here. So you see it automatically updates itself. So you have the quantity. Now when you select the shape, the one that we've calculated, you see you have the depth of the slab. Because you're calculating the volume, we want 100 millimeter slab, so you just edit from selecting the shape. So we have our volume, as you've seen the change it has made. So let's go to the next. In the insulation, you're going to use the area, so the same shape. Yes, for area I think it's fine. So next, for the stone, we're going to also have the area, so in meters, sorry, the volume. So we'll just use the same shape of the slab, so I'll also drag it, but we select the shape so that we can edit the depth. So basically for the volume, you always have to confirm from your details the depth of either the slab or the columns or whatever you need to calculate the volume on. Then you change it on the when you select the shape, you just change the depth. Yeah, so you can also drag if you want to see a page better. You can drag according to how you wish it. So for the geotextile, I'll also use the area. There's nothing else to change when it comes to the area. So on the damp proof membrane, okay, on the area, on like you can change a factor for quantities, like if you have a factor of safety, you can just edit on the shape that will apply like in that area. So I'm also going to use the same for the damp proof membrane. You can see the figure, the quantity changes according to your factor of safety. So it's just set automatically. So for the blinding, I'm also going to use the area, the same shape for the floor slab. And also for the compacted stone. For the compacted stone, I'm going to use the volume, and as we want we want it in 300 millimeter depth, so we're going to change it in our shape, the shape that the shape in the volume section to be 300 millimeters. So you have to select it, then select the shape, then we edit to 300. So that is element 19. Let me just delete so we can have the element 19 as the main heading. So I just want to show you how to format the description box. So this floor slab, let me just drag it under that. You can see how the heading now looks like with the drop down button. So to simplify, you can just use these arrows. You see as the drop down buttons for all the elements under your headings. So you need to be careful on making these headings, especially when using education, Cubit in educational format. We're usually given a limit of the number of tasks or on headings to add. So adding adding headings manually like this is makes it possible. If you have very many elements, you won't have a problem in adding more headings. So as I told you, let me just add the titles for element 19. That was the substructure we took off, and now we go to element 21. The element 21 are the external walls. So here we'll also have let me give an example of the few descriptions. At least here we'll get to see how the vertical area section works. So let's say we'll have concrete walls. For the external walls, we'll quantify the lintels. Maybe I'll also show you how to add some doors and some elements and some openings. So maybe let's say you have concrete lintels and you have steel lintels. So I'll give an example of how to calculate using the count section. So for concrete walls, we're going to start with the vertical area. So the same shape, because this is the external, we'll use the same shape because those are the external walls. But for the vertical area, we need to change this wall height. So your wall height, that's why you usually need your sections and elevations to check the height of your walls in your drawings. So let me see if these elevations that we have here have some more insight. I don't see any dimensions on this. Let me scale. So this will just give the scale 1:100. I think the scales in these drawings are correct. So yeah, there are some dimensions here. Let me see which one we're going to use. I think those are for the existing. For this building, I think this is the dimension. So let me use that 500 millimeters, 3.5 meters as the height of this wall. So you see, the quantity has changed for our wall of 3500 millimeters. So this is the section where you can also check the plans. You can toggle between plans that you had already opened, that will be of the that include the shapes, or maybe that you've opened in that particular session. So okay, let me go back to our plan, which let me check, let me just go through. Was it a site plan? No, it wasn't it. You're supposed to see the shapes that we have created. Yeah, here it is. So let's go for the concrete links. Let me just show you how to use the count result. So when you want to count maybe lintels that maybe this if you had a better plan that showed where a better position of the windows, so it's supposed to select automatically. So if it doesn't, just yeah. So let's go to the lintels. Yeah, the cross button, you just select and it automatically counts. Then you press enter, because when you press escape, it does not count. Even when drawing the shapes, when you draw a line, you want to end, I mean, when you want to cut the connection, you just press enter, because when you press escape, it will not measure. Yeah, so let's go to element 21, I mean element 22, which are the internal walls. So for the internal walls, let's say we have you have 100 millimeter block walls and 150, or let's say to 15 millimeters block walls. Let's assume that those are the two internal block walls that were used in this project. Yeah, so for both, we're going to do the vertical area. So I'm going to use the internal walls on the bottom half as the 215 millimeter block walls, and the others, the ones at the top, I'll use as 100 millimeters. So as I'd instructed, when you have that measured, press enter so that it counts. Then you can you can just continue there, press enter, another shape is generated. So I'm going to just select all these walls. Sorry, this is for a curved element. See, I pressed escape and all the whole shape went away. In the next tutorial, I'll have maybe a plan with some curves, and then I'll show you how to go about it. there. Press enter. Now all these shapes need to have a height of 3500. Yeah, so that all our internal walls have the same height, but it can vary. To know the height of these walls, you need to have better, I mean, maybe drawings of sections of the interior of the building, as well as well, elevations usually show the external, yeah, the external walls, but for the internal walls it's best to have some sections of the drawings, some internal sections. So you can change your colors, so that you can maybe differentiate between the 100-meter block walls and the 250-meter block walls after doing the takeoff or after quantifying, so that at least you can not get confused, especially if it's a big model where you have you have very many internal walls of different sizes in your plan, and you need to show them. And when you also drawing these lines, you need to draw them so that you're not confused, especially if it's a big model. So let me just do this so that you can see the difference in color. Yeah, so you see the 215 block holes are in purple and the other one are in peach color, I think. So you also can select all of them and just change the wall height together. Yeah, so we have all this. So here we can add, let me add some doors. We can do it as a new element. So measuring doors, windows and doors. Let's start with some doors, because I think the doors are clearer. So we're just going to do the door count. In Cubit, you can add different sizes of your doors. Here, when you go to insert your door, you'll have all the different sizes of doors. And if you don't find yours, you can import. You can import maybe a door from Revit, or you can just insert your exact specifications. So yeah, here you have the correct size. You just select on a line that you had already measured. So that is where you add the door. You can see, like in this, if there is no measuring line, the door will not detect. Like in here, we have to add this internal wall so that we can add the door. So a door and window will only be detected on a line that has already been measured. So when inputting the doors and windows, it's important to first have measured the walls, mostly because that's where we find. Yeah, Yeah, so now we can add our door. So we'll insert the same door. Let's insert one here. Okay, so I think it's decided to just start its own auto count. So I'll just auto count with the one that Cubit has given me, and then I'll delete the one that he had created. So insert the same door. So we have the one. So I'll just add to the places where we had those so that we just recount them, like there, there, and there. Yeah, I don't think we have any other doors for the double opening door. I don't think we have one here. So on that we have to create. We can just add our dimensions and manually create a door according to your specifications, mostly usually given in the architectural drawings. So here we have your quantities. So according to your research or according to the instructions, now the rate we add manually. Yeah, let's say in dollars, that's 120, and then let's just add some figures in the rate. Of course, you can use books like Spawn's book to get the rate of this element according to the country and according to the code that you need to use in doing your takeoff. So you see the totals are now adding up because Qubit automatically calculates for you, does the quantity times rate. Yeah, so it gives the totals according to the headings that you give. Yeah, and see the exclamation mark usually shows that there's a quantity that is not, maybe you've done a quantity and you've not included the rate. Revit shows you by using the triangle with the error. So you see when you add the rate here, the triangle disappears. So it just kind of gives you. So we can also use a factor according to your project also again, and also according to the rate, according to the country, according to the code. So this is just an example. So this is why you give the factor. It can't be 0 because that is a factor that is multiplied by the totals to get, by the totals to get the amount, the actual amount. Yeah, so I think everything is done, it's filled in. So you can see in the 3D we have calculated the slab, the walls, both internal and external. Just to confirm, actually the 3D is very helpful in just checking whether you've accurately captured all items. See, the doors are included, also the internal walls. Yeah, so we have everything. You can see simplified. Just use the drop down button, but in exporting your data, exporting your bill of quantities, it's going to print out in full. So you can just maybe generate a BOQ or a BOQ summary. You'll get it in a PDF form. So just give it just a few minutes. So when printing, this is how it's going to look like in PDF form. So you just print and save it in your computer. so that you're able to access it. You just say okay. Yeah, so when you save like that, you just save it to anywhere that you want in your computer. So I'm just going to save it here. So there are many reports that you can export from Qubit. The unit rates, the calculation sheets, the variations. Also, you can even export the plans with the shapes that you have modeled. So mostly you can just use that to in a presentation. Even the 3D that I've just shown you is something that you can print out for presentation purposes. So this is the summary. You can also save the image. Yeah, but the most important are the BOQs and the trade summaries, which will be bigger with a more detailed bill of quantity. So this is a way to export to other applications, which I don't think we'll be using. So to export this file, or you go back to the job manager, and then you right click and then you export, then you choose the folder or the file path that you want it to be saved. It will be saved as a cbx file format. So if you just want it in that folder, you just press ok, and then you'll go and find it in that folder. So then you export. uh, Come to the end of